Okay, good morning. Welcome to
FamilyMath791.
FamilyMath791. So this is a problem I saw from our friend Nassim and Taleb earlier in the week, and I thought I'd talk through it, and we talk about it and then study it. Everything okay?
Yep.
All right, good. So we got this is a problem that's a little bit above your level to be able to solve, but it's still very fun to talk about. An archer stands 1 meter away from a wall and shoots uniformly randomly to his right with his angle between 0 and pi over 2. Now you know what that means. What does that mean?
So it means that he's standing, if there's a wall, he's standing here and he's shooting between at the wall or parallel to the wall.
Okay, but
kind of 0 to 90 degrees.
0 to 90 degrees. So there's a different way to measure angles using highs. Yeah, using radians. But pi over 2 is just 90 degrees. So an archer stands at a wall, decides an angle between 0 and 90 to shoot at, and then shoots at that direction, and then the arrow hits the wall.
So the arrow just goes until it hits the wall?
Yeah. So we're going to be in that kind of pretend world where that could happen.
Alright.
What is the average distance in meters between the arrow's mark and the spot on the wall 1 meter in front of the archer? So do you want to draw a picture for this?
So like we have the wall.
An infinitely long wall.
Right. We have an infinitely long wall.
And then we have an archer. It's like standing.
Well,
here.
we're gonna label it as 1 meter, but like put it up here just so it's easier to see. Okay.
So he's shooting at an angle. So is it shooting between here and here?
Right.
Or,
well, yeah. To the archer's right. That's fine. It doesn't matter if it's left. So you can draw it however you want.
He's shooting between anywhere between these two lines, and he's like picking angles to shoot at. So like you could pick like a 45-degree angle.
That's right.
It would shoot here.
Uh-huh.
A 90-degree angle would never even hit the wall.
Right.
And then a 0-degree angle would just go directly at the wall.
Yep. And that's the spot directly opposite the archer on the wall. So why don't you label that spot? And what distance are we trying to measure?
We're trying to measure this distance here, this average distance from the archer to the wall.
Not quite. We're trying to measure, mark a spot directly in front of the archer. What is the average distance in meters between the arrow's mark and that spot?
So it's this distance from that spot to wherever it lands.
Okay.
Although this distance might help us find that distance.
Well, maybe. So what are some things in this diagram that we know, or do you think might be important?
Well, we know this.
That's
There's 1 meter.
Okay.
This distance is probably going to be important.
And
the distance that the arrow travels. And we know it's perpendicular.
Yeah, we know that's perpendicular. Okay.
So, in some cases, we would know in all cases we would know the angle up here.
Okay. What should we call that angle?
Angle N.
N. Okay. Angle N.
And for some cases, like the 45, we would know we would create some special triangles. So like if this was 45, this would also be 45.
That's true.
Although in general, it's just we won't really have a special triangle.
Yeah. And what are we trying to find? Let's make sure we label what we're trying to find. What do you want to call that unknown?
X.
Okay.
So we're trying to find this distance to wherever it lands.
Okay. Good. Do you know any way to relate N and X here?
Yeah, because you can use trigonometry, and you know that tangent of angle N is x over 1.
Okay.
So you know that I guess x is tangent N,
Okay, so if we know trig, and you haven't studied trig yet, so that's okay. There's a what's called a trig function called tangent, and the tangent of the angle is the distance we're trying to find.
All right.
Okay. So before we go to the computer to study this a little bit, what do you think the answer is going to be? What do you think this average distance is going to be?
Well,
Actually, let's do that in a second video.